In this video, what we're going to do is we're going to look at the basic use cases of our deferred and our deferred of result. So I'm going to start off with a very simple instance, a very simple asynchronous operation, which is basically just going to be an operation that sleeps on a thread for X amount of time, and then when it's done, it will resolve the deferred or set its result to true. So the way that I'm going to write this method is I'm going to say static deferred, I'm just going to say wait, and I'm going to say int milliseconds. Now, we won't write this just yet because let's talk about what this method should do. Now, what this method should do is it should return immediately. So it should return back to its caller immediately, but then it should invoke the deferred when it's done after X amount of milliseconds have passed. So the output that we're going to do, I'm first of all going to come up here to the top, and I'm going to nuke all these usings, and I'm going to say using static system.console, and what that'll allow me to do is it's the C# feature. It imports all of the static members of console, so now I can just type in write line, and I'll be using this quite extensively. So we'll do start, and then what we're going to do is we're going to say wait, and we'll wait for 2 seconds, and then I'm going to say on success console, or sorry, write line done. Then what I'm going to do, now the thing about this is, so this wait method is going to start its own thread, it's going to wait for 2 seconds, right? And then when it's done, we have to ask, so what thread is it going to be invoking its callbacks on? Now, I'm going to keep things simple with the deferred API. If you want to do any sort of fancy thread synchronization where the result method gets dispatched onto the thread that called it, we can do that on a case-by-case basis. But for now, this onSuccess method is going to be invoking on the thread of the deferred. It's important to note, however, that deferred doesn't necessarily have to use the thread. So anyway, then we'll do write line waiting. Now that means that this deferred will return immediately, which will close the program once it's returned, but before it's completed. There's no delay going on here. So what we have to do is we have to write our own delay code. So I'm simply going to say read key. So read key is going to pause the main thread until you hit a key. So this is what a basic usage of a deferred would be. So let's open this up and let's write the simplest implementation of this. Let's say var def equals new deferred, and then I'm going to say def.setResult true, null, and then I'm going to say return def. So this is the simplest thing. All we're doing is we're immediately resolving the deferred after we create it and returning it. So let's hit F5, and what you're going to see is, well, nothing's going to happen. We're going to go to start, then waiting, because we haven't implemented the setResult method yet. So let's go ahead and do that. So we need to implement the setResult and the onSuccess methods. So jumping into deferred, let's scroll down here. So we have, we're going to be doing onAlways and then onSuccess and setResult are the primary methods that we need to write in order to implement this functionality. So onAlways is, first of all, what we're going to do is we're going to say lock this. We're going to enter lock. Now, I'm sure there would be a way to make a lockless implementation of this. That's something I'm going to consider in the future. Right now, I'm not worried about the 50 nanoseconds required to enter a lock in .NET as far as performance goes. But of course, if it becomes a problem and we find it being a problem, we can investigate a lockless solution. So then what I'm going to do is, on always, I'm first going to check to see if we've already resolved. So I'm going to say, if we have a result already, then simply invoke the callback with this, and then return this immediately. If we don't have a result, then set our callbacks to plus equals callback, like so. And that's it. So this is our on always. If we have a result, immediately evoke the callback. If we don't have a result, add it to the callback list. So now let's do our on successes. These will be pretty straightforward. All we're going to do is return on always, and then we're going to open up another closure here, and I'm going to say if def.isValid, then callback def. So this on success is built on top of our on always. And we can do another on success here, which will be return on always def If def is valid, then callback. But remember, this is the onSuccess that doesn't have a deferred parameter on its callback. All right, now we have to implement setResult. So setResult is going to be pretty straightforward. All we got to do is come up here. We have to lock this to make sure that we're not manipulating our callback list while this happens. I'm going to say if hasResult return, because we don't have anything to do. We've already set the result. If we set the result twice, we don't want to invoke the callbacks again or anything like that. Then I want to say isValid equals isValid, error equals error. And then all I have to do is say callbacks this, and then callbacks equals null. So by doing callbacks this, that's going to invoke every single callback that has been attached to that invocation list of the delegate, which you'll notice down up here happens right here on line 55. So what this plus equals does is it takes the delegates, it combines them and returns them. I also want to really stress right here that this is that delegates are immutable, meaning what we're getting right here is a new copy of our delegate with our invocation list, including what used to be there, as well as what we just added. So it is immutable. Now, that's actually incredibly important, because if we scroll up, notice how we're all starting on this empty. Notice callbacks equals empty. Well, if it wasn't mutable, or if it wasn't immutable, if every time we did callbacks plus equals do this thing, then it would be assigning it to empty's invocation list, which would be everybody's invocation list, which would turn into a huge mess. But fortunately, delegates are immutable, meaning when we do that plus equals, we're creating a new delegate with the old list and the new list combined. So now all we have to do is invoke callbacks like this down here. And then we set it to null, which signals to the deferred that we have a result finally. Alrighty, so let me scroll back down to onAlways and setResult. Well, actually, I'll just do a quick scroll down of what we've implemented already. We have onAlways right there, and then we have our onSuccesses, and then we have our setResult. Pretty straightforward implementation. Let's hit F5. Now we see start, done, waiting. So what goes on here? Well, we create the deferred, we immediately set its result, we return the deferred, then we do onSuccess, and we write done. Then we start waiting. Now let's go ahead and simulate an asynchronous operation. So what I'm going to do here is I'm going to say new thread, and then I'm going to say .start. So this then I'll also remove this def.setResult, obviously. Now inside this new thread, I'm going to say thread.sleep milliseconds, and then I'm going to say def.setResult true null. Now let's hit F5. So now we get start, waiting, and then 2 seconds later we get done, which is exactly the behavior that we're looking for here. Because remember, we want to wait 2 seconds before we resolve that deferred, and our onSuccess callback can then be invoked. Alrighty, so there's our basic wait. Let's go ahead and test our onAlways and onFail. So I'm going to do onAlways. Right line. Looks like I don't have a... You know what? I want to fix that. I'm going to add a overload to onAlways. I'm going to go ahead and say public deferred onAlways, taking in an action of callback. And this will simply return onAlways. Def goes into callback. So now we have a simpler way to do our onAlways. And then we can do an onFail. Now for the onFail, I will... the only onFail method that's available to us is one that takes in a deferred. I might change that too, but I won't worry about it right now. And then we'll do error, and I'll go ahead and use string interpolation here and say def.error. So now if we get a failure, we'll get an error. So now if we run this, we'll get our start waiting, and then we'll get our done and our always. But now let's go ahead and introduce an error condition. So up here on wait, let's set result to false, and then the error to something. And let's hit F5. And now we get our start, our waiting, and our always, but we don't get our failed because we haven't implemented those yet. So let's jump back into deferred and write in our failed. So on fail, return on always def, if def is valid, return, otherwise callback. Well, no, I'll keep it consistent with the way I implemented the other ones. I'll say if not def is valid, callback def, and then our other on fail will be return on always def goes into if not def is valid, then callback. Oh, it looks like I already did have that other on fail. It's just I messed up the casing because of course I did. Alrighty, let's jump back into program and hit F5, and now after 2 seconds we should get an error. And we do. Alrighty, so far not terribly exciting. Now there's definitely some things that we're going to be doing later here that will be more exciting, but for now that implements a large part of our API here. I mean, really all we're missing are the more advanced features, the join, then, and then. However, we're also missing our deferred of t implementation, so let's go ahead and do that. I'm going to change my wait method to be wait and then string result, and I'm going to have it return a deferred of string. So to instantiate a deferred of string, we simply instantiate a deferred of string. And then on our set result, what we're going to do is we're going to set is valid to true, error to null, and then our result to result. So the result I'm pulling from the parameters here and capturing it in this closure, and then passing it off into the deferred. But the idea here is on my onSuccess, I now want to be able to extract out that result. So right here, I'll say def goes into console right line, and I'll do string interpolation, and I'll pass in done of def dot well, it looks like I completely forgot to turn that into a property. So let's go ahead and fix that first. Jumping into deferred of 1, my result, I want to be a property. So I'm going to go ahead and encapsulate field and do a private set. Now, notice what resharper turned it into immediately. It turned it into a get. And what this is this turns it into a property with a read-only backing field, which isn't what we want because when we set the result, we want to be able to set, well, the result. So instead of that, we're going to do get private set, which get private set turns it into a property with a backing field that can be retrieved outside of the class or set inside of the class. So now let's scroll down and let's implement our on always, on success, and on fail. So that's really interesting the way that this works. I'm basically overloading these so that if I click here onto on success and hit F12, look at which on success we jump into. Through the magic of C#'s overload resolution algorithm, it correctly determines that this is the onSuccess method we want, which is the onSuccess method that returns a deferred of t result. The onSuccess method we don't want is this guy right here. But you'll notice this, so if you think about it, this onSuccess method is named onSuccess, and it takes a parameter, and that parameter is a delegate that has a single parameter, right? If we come over here, this is a method named success that accepts a single parameter that is a delegate that accepts a single parameter. But through the magic of the C# overload resolution system, we don't have to override this. We don't have to set it as new. We can just write it, and it will be used properly as the types propagate. So, I don't know. I thought that was really cool and very clean, I guess. And I hope you guys enjoy that because it makes things awesome and easy. So, what are we going to do here? So, our on always, basically, the way I want to implement this is to base it off of the on always that we already have. So I'm going to say return on always, and for this, what I think I'm going to have to do though is I'm going to have to return base.onAlways, and then I'm going to have to return base off on always def goes into, And then this callback, which I called onAlways instead of callback for some reason, so let's change that name there. And deferred of t result, which is going to be this. Oh, right, this isn't going to work. I'm going to have to say base.onAlways and then return this. I'm going to have to return this here because this onAlways returns a deferred, not a deferred of t. Whereas the onAlways we're in returns a deferred of t. I know there's a lot of weird operator or overload resolution going on here, but it does work. So stuff and things. I hope you guys understand why we can't return the result of this base onAlways, and we have to basically redefine it here. So our onSuccess is now basically going to be a carbon copy of the onSuccess of our previous class. So we're going to do onAlways, and we're say def goes into callback of def. Which actually, derp, that's not what I want at all, because I want to say if def is valid, then invoke callback of def. Now this is using, see if I click on this, you'll notice I'm getting this method right here. So this is using the correct overload. Next up, we'll do onFail, which is onAlways def. Def goes into if def is not valid, then callback def. There we go. Now we need to implement our set result. So our set result is going to be very, very, very easy, because basically all we're going to have to do is say set result is valid error, and then is result set equals result, and result equals result. Or whoops, is result set equals true. Sure. Okay, so this set result that I'm invoking here is the base set result. I can make this a little bit more obvious in the code by specifying base.setResult. Now Resharper will tell me it's unnecessary, but honestly I think that it makes it a little bit more clear that we're invoking the base deferred set result so that we get our is valid and error propagated through that, but then we have an opportunity here to set the is result set and the result equals. In fact, I should have done that before that. Now that I think about it, there's a potential raise condition here, but I'm not too worried about that. All right, now let's go ahead and hit F5. We have start, waiting, done with result of 1. And now we can come up here and change the set result from true, null, result. We can now set it to false, error, and we should also get our error. So we're properly reusing our base class. So that means all deferreds of t's are deferreds. All right, so I have another example in mind that's going to make this a lot more interesting, and it'll also play into what we're going to be doing in the next video. But let's go ahead and click over here to deferred, and it's assigned, but its value is never used. Oh, right. The only time I use is result set is in the save and load methods. So we don't have to worry about that error. Anyway, so let me scroll down. We have our constructors, which just to make it clear that they're not empty, I can move the base invocation down a line to indicate that they are in fact invoking the proper constructors on the base type. We re-implemented onAlways, and then we added another onSuccess and another onFail. We implemented our set result. So now all we have here is join and then left. But join and then we won't be able to really play with or understand until we get a little bit more of a complex example going. So actually, I think I'm going to go ahead and leave the video here, and then the next video we'll pull up this example. But I just wanted to point out that, well, I guess I can give you guys an idea of where I wanted to go with this. So I want a static deferred. Let's do static deferred. Well, it doesn't matter if it's typed or not typed. And wait. But what I wanted to do is, let's nuke all this code because we don't need it. I wanted to change this a little bit. Deferred of wait, and then I wanted to put in a int milliseconds, and then an action. And then I wanted to do var def equals new deferred, return def, new thread, passing in a thread start of that, immediately starting the thread, and then saying thread.sleep milliseconds. Then I'm going to say try and catch. And for the try, I'm going to say try action followed by def.setResult true null. And the catch, we'll take in an exception E, and we'll say def set result false e.message. So this really, really simple wrapper is going to be very similar to a lot of the code that we're going to be writing when we integrate this deferred system in with Photon. So the idea being is that I can now say something like, wait 2 seconds and do this thing. And what thing is this going to be? I don't know, console write line, or sorry, just write line, do something, followed by an on always of write line something done, and an on fail of res goes into write line fail. Actually, I can go ahead and turn these all into expressions like that. Actually, I don't want that one to be an expression for readability. And then we'll do our on always and our on fail. So now we have this wait 2 seconds, and we have this write line do something, and then we have an on always and well, let's do an on success here. Hit F5. Now we'll see what we saw before. Start, waiting, do something, something, done. But now all we have to do inside of this is cause an error. For example, throw new exception. And now notice that after 2 seconds, fail, something can't be done. So we've managed to capture the exception. So a lot of our code is going to actually be running in these sort of wrappers that you see right here, where the wrappers will try to invoke some sort of action on some different thread somewhere, or after a specified amount of time or whatever. And if it throws an exception, that exception then gets set on the deferred. Now this is incredibly important for really anything that has to do with stability of the server code. We want at any point the server throwing an error to be able to eventually notify the client that something bad happened. And to do that, we can use these sort of wrapper methods. Now these wrapper methods get a lot more interesting, or will become a lot more interesting when we start looking at join and then. But I guess we'll look at that in the next video, and hopefully I'll have a better example thought up here of how to explain that by then, and I guess we'll see you then.